Now the last example I'm going to give you on these particular types of problems are the one for corresponding angles. So corresponding angles just means that relatively we have an angle that's in the same relative position. So for instance, I'm just going to give you an example. This angle is a corresponding angle to this one right here. And the reason is because this is on the top left of a parallel line. And I say it's on top of a parallel line, I should say, and left to the transversal. So it's the top left position. Now if you look right here, this is also a top left position because it's on top of the parallel line and it's to the left of the transversal. So because both of these are in the same relative position, they're above a line and to the left of the transversal, we say that they're corresponding angles. Now we're going to use this definition so that we can solve for x and then find what this angle is. So let's first solve for x. So if we want to solve for x, we're simply going to take this first one, 11x plus 9, and we're going to set that equal to this bottom left, 13x minus 3. This one I didn't tell you which one was bolded. It really doesn't matter which one I solve in this expression. I'm just trying to find the angle. My goal at this point is trying to find what is the angle of these corresponding angles right here. So I'm going to go ahead and draw my line through my equal sign. And I'm going to do as always, I'm going to start with a constant. I'm going to move my constant to the right side of the equation. So I'm going to subtract 9 because that's adding 9 right there. That leaves me with 0 on the left, and then I'm going to subtract 9 on the right. And notice over here, right, we just have negative 3 plus negative 9. So negative 3 plus negative 9. And that gives me negative 12. Then I'm going to take this variable right here, right, 13x, and it's a positive 13x, and I am going to subtract it. So we're going to subtract 13x, that zeroes out our variables on the right side of the equation. And then I'm going to subtract 13x here. And so we have a positive 11 plus negative 13. So 11 plus negative 13. And it gives me negative 2. So I now have negative 2x. Now in this case, right, we cannot have a coefficient other than positive 1 for our final answer. So I want to get rid of this coefficient of negative 2. So therefore I'm going to use inverse operations and I'm going to divide by negative 2. That'll go to itself one time, which simply leaves me with x is equal to, and if I get my calculator on this second one, right, I'm going to use my fraction bar. I'm going to hit alpha y equals, enter, and I have negative 12 over negative 2. And when I divide it, hit enter, it tells me that it is now a positive 6. So my x value, if it asked me to solve for x in this problem, my answer would be x equals positive 6. On the other hand, if it wanted me to find the angle for one of the expressions, I would just use that expression and substitute 6 in place of the x to get my answer. Now I'm going to use this bottom left one, so I'm going to go ahead and rewrite 13x minus 3. The only difference is I am going to replace x with what we found x was equal to, which is 6. So I actually have 13 times 6 minus 3. And I'm going to put that into my calculator to evaluate it. So 13 and parentheses 6 minus 3, and that gives me 75. So this angle is 75 degrees. So this is a 75 degrees angle, which means by definition of corresponding angles, this other one up here that's in the same relative position is also 75 degrees. So now I have solved for x and I solved for the angle. Make sure that you read your problem to see which it's asking for and follow the same process.